Okay, this is 5.5 day 2. We're introducing what's called the rational root theorem. This theorem basically is a way of finding possible roots to a polynomial. It's not that these are roots, it's that these are possibilities. So, for example, if I had the one, let's say 10x squared plus 3x plus 24 or minus 24. Okay, and for this, positives and negatives don't matter. But what this basically says is, if I put any factor on top of the last one, so any factor of 24, so that's 24, 12, 8, 4, 6, 4, 3, 2, 1 on top, I can divide it by any factor of 10. That's 10, 5, 2, and 1. So, and it could be the positive form of it or the negative form of it. Now, so basically my point is this. Any one of the numbers on top, so like 4 divided by 5, so 4/5. A positive or negative 4/5. Not 6/5 work. Let's get rid of those circles. I could pick a 3. I could do 3 divided by 10, 3 divided by 5, 3 divided by 2, 3 divided by 1, so just 3. Plus or minus 3 divided by any of those would work. Now, here's the deal. This isn't to say, hey, we're going to try every last one of these to figure out what the root is. No, that's crazy. But in the realm of every single possible number fraction that we could possibly come up with, this narrows it down significantly. So basically, if you said something like, well, I think 400,000 is a root, well, we can promise you it's not, because 400,000, nothing up here divided by anything down there will ever equal 400,000. All right? So that's essentially what the rational root theorem says. You take the c value, the very last term, and any of its factors divided by any of its factors divided by any of the factors from the leading coefficient is a possible root, possible solution. So for this one, I can think, oh, well, 7 is my constant, so its factors are simply 7 and 1. Over here, 2 is the constant. 2 is the leading coefficient, so any of its factors, 2 or 1. And we can do positive forms or negative forms. It does not matter which. And what this asks is, which of these 4 are not a possible solution? So 3.5. So if I take 7 and divide it by 1, I get 7. Okay, well, that means this is a possible root, so that's not out. If I take 7 and divide it by 2, well, 7 divided by 2 is 3.5. So that's a reasonable root. That's not one of the ones it's looking for. All right. I can take 1 and I can divide it by 2. So 1/2. That's 0.5. Well, that means that's not the answer. Let's get rid of those. The only one left is 2. And if you think about it, 7 divided by 2 is not 2. 7 divided by 1 is not 2. 1 divided by 2 or 1 divided by 1. No way to do any of the numbers on top divided by any of the numbers on bottom will ever give you 2. Therefore, 2 is not a possible root. Okay? 2 cannot be a root for this. Now, that doesn't mean that 7, 5, and 3.5 are roots. It just means 2 is not possible. Okay? It's kind of one thing we got to keep in our mind a little bit for this. So, number 12. Based upon the rational root theorem, I can take any factor of 20, and I can divide it by any factor of 1, which the only factor you've got is 1, and it is a possible root. So you've got factors of 20 are 20, 10, 5, 4, 2, and 1. Those are all possible factors of 20. And the only factor up front is a 1, so that's the only possible factor of that are gone. So any of these are whole numbers, so that's really nice. So we could pick 1, 2, 4, 5, 10, and 20. Pick any of those and try them out. What I'm going to do is I'm actually going to go to my calculator and I'm going to plug this in and I'm going to look at the graph. And I'll do that real quick, and let me draw it real fast. Give me a second. Boom, there you go. Like I said, give me a second. And there's the graph. That's rough estimate of what the graph is on the calculator. And so, based upon that, I can probably say that the answers are 5, 4, and -1. Now, if you just put those down as your answers, I'm not going to give you much credit because I'm going to show you how to mathematically do this. We have to test to make sure they really are the roots. Remember, this just gives you all the possible roots. It doesn't prove that they are. So here's what we're going to do. We are going to use synthetic division to check it out. And I'm going to pick one of those. So let's start with 4. Why not? Or actually try -1 because I like multiplying by -1. So we're going to see if the x value, -1, gives us a y of 0. So -1, -8 for my x squared, 11 for my x, and 20 for my constant. So remember, drop it down, multiply, add, multiply, add, multiply, add. So we'll drop down the 1, multiply by -1 is -1, that's -9, multiply by -1, that's +9. 11 and 9 make, not times 9, plus 9. 11 plus 9 make 20. 20 times -1 is -20. Great, and we get a remainder of 0. Excellent. So, for this function, when x is -1, y is 0. Therefore, -1 is one of our roots. So x equals -1. We have just proven that -1 is one of the roots. From here, the easiest thing to do is to look at this. Remember, this is your x to the 0. This is my x to the 1. This is my x squared. So let's see here. This is x squared minus 9x plus 20. And that is factorable. I can do an x minus 5 and an x minus 4. Because 5 times 4 is 20, or -5 times -4 is positive 20. And when you add them up, they equal to -9. So when you set those equal to 0, you get x is, move over, x is 4 and x is 5. And there you go. Those are the real roots. We use the calculator to find possibilities. We use synthetic division to prove that one of them was, whereas normally I would tell you to try and factor this, but this really doesn't factor. Factoring by grouping doesn't really work for it. It's an ugly one to try. It just doesn't work out that way. And some of them are that way. Just how it is. So, here we go. Let's try number 13. Number 13, find all the real zeros of the function 3x to the 4th plus x to the 3rd minus 40x squared minus 32x plus 40. Pause the video, stick this in your calculator, and that way we can both look at this. And boom, there you go. Number 13, as you look at the graph, we're going to say, well, that might be a half, that might be like a third, that might be -1, 2, 3, 4, -3 halves, this might be a positive 3 halves, but it might also be a radical. This one, which I didn't draw very well, this is the only one that's clear. It's a very good chance that is right there at -4. And -4 is a possibility because, pardon me, 16, not 16, yeah, because and 4 is a possibility. That's right, -4 is a possibility because 12 is a factor of 48. Is a factor of 48, and 3 is a factor of my leading coefficient. 12 divided by 3 is 4. So 4 is a plausible one to try. So here we go. 4, 3, 11, -40, 132. 3, 11, -40, -132, and 48. And then I'll clean up this tab over here. So here we go. Remember, drop it down, multiply, add, multiply, add. So, get out rid of the eraser. 3 times 4 is 12. 12 plus 11 is 13. 13 times 4 is 52. 52 minus 40 is positive 12. 12 times 4 is 48. This one looks like a pain, so negative 132 plus 48. So I don't feel like doing that in my head. That's negative 84. I think I did something wrong. I did do something wrong, and hopefully somebody caught it way back early. When you do 11 plus 12 is not 13, it is 23. So here we go, let's try this again. Only takes one little small mistake. 23. 23 times 4 is 92, minus 40 is what? 52. 52 times 4 is 208. Minus 132 is 76. Oh, I know why I'm not getting the right answer. Mr. Hunter's a doofus. Let me try this again. Here's why. This point over here is a negative 4. Oh. So a positive 4 is not going to work. More than likely. Just from looking at that. So 3, 11, negative 40, negative 132. That's not a 90, that's a 40. Negative 40. Negative 132. And 48. So let's try this again. You get to watch Mr. Hunter fall on his face. So 3. 3 times 4 is negative 12. Negative 12 plus 11 is negative 1. That's positive 4. That's negative 36. Negative 36 times negative 4 is positive 144 minus 132. Should be what, 12? Yep, that's 12. 12 times negative 4 is negative 48. Good. And that's a 0. Good. So negative 4 is one of our roots. It worked that time. And so, here we go. This is our x to the 0, or our constant. This is our x to 1, x to 2, x to the 3. So, now, we know that 0 is one of our answers. So, x equals 0. That's one of your roots. We also know that f of x, one of our factors, is also 3x to the third minus x squared minus 36x and minus 12. And I look at that and I think, wow, you know, I think factoring by grouping might actually work on this one. So I'll divide the first two by x squared, and that is supposed to be a positive 12, by the way. And I'll divide the next two. I need to flip that sign, so I'll divide the next two by negative 12. So here we go, x squared, so that's a 3x minus 1. And if I pull out a negative 12, 36 divided by 12 is 3, so that's 3x minus 1. There we go. So we have a 3x minus 1 and an x squared minus 12. And that is a difference of squares. So so we got a 3x minus 1 is one of them. And then x minus the square root of 12 is 1, and x plus the square root of 12 as the other. So when I set them equal to 0, this turns into a 1/3. This turns into a positive square root of 12. This is a negative square root of 12. So our answers are 0, 1/3, and plus or minus the square root of 12. And I know some people might look at this and say, hey, you know, you could have used synthetic division again, but I would have had to guess 1/3 to get it to work right. Or I would have had to have guessed positive or negative the square root of 12 to get it to work, whereas I could have factored it and just finished it. All right, so those are your roots. All right, last one for this video. Again, I'm going to start off by using my calculator. I don't even want to think about just guessing something that really works into that. So I'm going to put this in my calculator and I'm going to get a quick graph. So here's my graph. And as I look on my graphing calculator, I notice the only one that really looks like a whole number is this one right here, positive 1. So I'm just going to go ahead and try it. The rest of them are in between, so unless I want to guess fractions, I really don't feel like it, we're going to go with it. So it's a positive 1. Draw our chart. So we got 3x to the fourth, negative 2x cubed. My x squared is negative 27. My x is 24. And my constant is 12. So remember, drop down, multiply, add, multiply, add. So pull out the 3. 3 times 1 is 3. Minus 2 is 1. 1 times 1 is 1. So that's a negative 26. 26 times 1, again, that's a negative 26. Plus 24 is a negative 2. And I could have sworn this one worked. 3 minus 2, 4, 3, 2, 1, 0, 4, 3, 2, 3, negative 2. Oh, that's a 37. That's a problem. Well, there's your problem. That's supposed to be a 37. Makes a difference. So here we go. 1 times 1 is 1. So that's a negative 36 times 1. That's a negative 36. Negative 36 plus 24 is negative 12. Times 1 is negative 12. Adds up to 0. So since it enters 0, that means 1 is one of our roots. It means we have the point 1, 0 on our graph. So x equals 1. We know that. And from this, we also know that what's remaining is the polynomial 3x cubed plus x minus 36x minus 12. And I think I just literally factored this. I think this was part of the last question, come to think of it. If you don't remember it, just go back and look. But those, we can factor that by factoring by grouping. So I'm going to divide, that should be an x squared, by the way, an x squared out of the first, so that's 3x plus 1. And I'm going to divide a negative 12 out of the second, negative 12, so that's, again, 3x plus 1. Oh, it's a 3x plus 1 instead of 3x minus 1. Big whoop. So I got 3x plus 1 right here, and then I have x squared minus 12. And again, since there's a negative in between there, that's a difference of squares. So we have 3x plus 1, and we have x plus the square root of 12, and we have x minus the square root of 12. So our factors are 1, negative 1/3, which the last one was positive 1/3 if I remember, and then we have plus or minus the square root of 12. And those are your factors.